Welcome to the Tech latest Stable Diffusion video series. In this video, we are going to discuss about Stable Diffusion models and provide step-by-step instructions on how to install a new model, as well as how to use and merge them. Pre-trained Stable Diffusion weights, also known as checkpoint files, are models designed for generating images of a general or specific genre. What images a model can generate depends on the data used to train them. A model won't be able to generate a skyscraper's image if there's never a skyscrapers in the training data. Likewise, if you only train a model with castle images, it will only generate castles. There is a term which is quite common in Stable Diffusion: fine-tuning. Fine-tuning is a common technique in machine learning. It takes a model that is trained on a wide dataset and trains a bit more on a narrow dataset. A fine-tuned model will be biased toward generating images similar to your dataset while maintaining the versatility of the original model. Now the question arises, why do we need to fine-tune models? Although Stable Diffusion has its advantages and is trained on a huge dataset, it may not excel in every scenario. While it can easily produce anime-style images by using the anime keyword in the prompt, generating images of a specific subgenre within anime may pose a challenge. Instead of trying to modify the prompt to achieve this, a better approach would be to fine-tune the model using images from the desired subgenre. There are two primary techniques for fine-tuning, namely, additional training and using Dreambooth extension, both of which begin with a base model such as Stable Diffusion version 2.1 or version 1.5. Additional training involves training a base model with an additional dataset of interest. For instance, one can train Stable Diffusion version 2.1 with a supplementary dataset of vintage cars to introduce a bias towards this subgenre in car aesthetics. Dreambooth, which was initially developed by Google, is a method for integrating custom subjects into text-to-image models. It requires only 3 to 5 custom images to function and can be used to incorporate personal images into the model. To condition the model, a unique keyword is needed for the model trained with Dreambooth. We have a separate video of Stable Diffusion Dreambooth feature, where we explained step-by-step how to train our own model with few images and generate the checkpoint. Links are in the description. At the time of recording this video, there are two groups of models: version 1 and version 2. There are thousands of fine-tuned Stable Diffusion models. The number is increasing every day. We'll discuss few models here. Stable Diffusion version 1.4 was released in August 2022 by Stability AI. It is considered to be the first publicly available Stable Diffusion model. You can treat version 1.4 as a general-purpose model. Stable Diffusion version 1.5 is released in October 2022 by Runway ML, a partner of Stability AI. The model is based on version 1.2 with further training. Like version 1.4, you can treat version 1.5 as a general-purpose model. Version 2 models, Stability AI released a new series of models version 2. So far 2.0 and 2.1 models are released. With version 2, you can add a higher resolution version of 768 x 768 pixels in addition to 512 by 512. However, the Stable Diffusion community found that the images looked worse in the 2.0 model. People also have difficulty using powerful keywords like celebrity names and artist names. The version 2.1 model has partially addressed these issues. The images look better out of the box. It's easier to generate artistic style. As of now, most people have not completely moved on to the 2.1 model. Many use them occasionally but spend most of the time with V1 models. Now let's see how to use Stable Diffusion model. If you are using Stable Diffusion solution provided by techlatest.net on cloud platforms, that is Google Cloud, AWS and Azure, then you can follow along with each steps. But if you are having different setup, then please make changes accordingly. Techlatest Stable Diffusion is installed on a Linux machine, and Stable Diffusion setup is available under Ubuntu Home Directory. Navigate to Setup, and here we have Stable Diffusion Web UI. Now, in this setup, model directory is as shown here. To install a model in Automatic, download and place the checkpoint file that ends with .ckpt in the model folder. Hugging Face offers a variety of models to choose from, so you are free to select any of them and give them a try. For this demonstration purpose, I have used Stable Diffusion 2 depth model, which is available for download from here. For installing the model and CKPT file, we have to use some commands. Let's start. First, we run sudo su ubuntu command to enter in Ubuntu on the terminal. After this command, we moving to Stable Diffusion model directory using the cd command as shown here. With lsltrh command, we'll check the list of downloaded models. After this, you can simply copy the checkpoint file address from the Hugging Face. Right-click on the Here button and copy the address. Use the wget command and paste the address of the model we copied from Hugging Face. It will download the model in Models directory. Once completed, again check with lsltrh command. Once you downloaded the checkpoint model file in the checkpoint directory, restart your Stable Diffusion environment. After restart, open the Automatic1111 web interface and press Reload button next to the checkpoint drop-down in the top left corner. You should see the name of the newly downloaded checkpoint model file. Select the new checkpoint file to use the model and generate the images using it. This is all about adding new models. Now suppose we want to generate our own checkpoint by merging two or more models. We can achieve this with the checkpoint merger feature. This feature is already available with the Automatic1111 web interface. Go to the Checkpoint Merger tab and select the two models you want to merge in the primary model, A, and the secondary model, B. Change the settings here, as per your requirement. Once ready, click on Merge button. It will take some time. There are four main types of files that can be called models. Checkpoint models. These are the real Stable Diffusion models. They contain all you need to generate an image. No additional files are required. They are large, typically 2 to 7 gigabytes. And we just discussed about them in this video. Textual inversions, also called embeddings. They are small files defining new keywords to generate new objects or styles. They are small, typically 10 to 100 kilobytes. You must use them with a checkpoint model. LoRa models. They are small patch files to checkpoint models for modifying styles. They are typically 10 to 200 megabytes. You must use them with a checkpoint model. Hypernetworks. They are additional network modules added to checkpoint models. They are typically 5 to 300 megabytes. You must use them with a checkpoint model. That's all about this video. We discussed about pre-trained Stable Diffusion weights or checkpoint files, which are used for generating images. The type of images a model can generate depends on the data used to train it. We also discussed about how to install new models and use them. And at last we saw how to merge two or more models using checkpoint merger. TechLatest.net provides the Stable Diffusion with Automatic1111 web interface offer in the form of a virtual machine solution on leading cloud platforms including Google Cloud, Amazon Web Services, AWS, and Microsoft Azure. To ensure you have the best learning experience and can follow the course content seamlessly, we highly recommend provisioning the pre-configured Stable Diffusion virtual machine solution available on these cloud marketplaces. Here's how to get started. Go to www.techlatest.net/sd. Click the provided cloud provider marketplace link. Follow the on-screen instructions to launch the VM. To make the provisioning of VM easy for you, we have step-by-step guides, which shows all the steps in details. All the links are in the description. Thank you for watching.